We have said that we have summation notations for one variable, for two variables, and for more than two variables. This is commonly referred to as univariate summation notations, bivariate summation notations, and multivariate summation notations. Here, we said we shall deal with the summation notations involving one and two variables, that is univariate and bivariate summation notations. Summation notations involving one variable are the ones we call univariate summation notations. We are dealing with an example to describe this. We said, assuming that we are dealing with a variable like a weight, we can algebraically denote it with W. Some of you have forgotten your algebra, but algebra, I remember in P4, P5, or senior 2, it is the calculation with symbols. So in algebra, we like to calculate using symbols. And we don't fear symbols because symbols are just created by men as to represent certain variables. For example, here, we algebraically, or we use a symbol W, a letter W, to represent weight. Because in statistics, we always want to summarize everything. We don't want lengthy write-ups. So instead of writing the full word weight, you simply write W to represent weight. As long as you are able to define it, and you say the W. Enosh, please unmute, mute yourself. And Ambrose, also mute. Joshua, also keep yourself mute. And Ambrose, keep yourself mute. You are interrupting our class. Whenever we tell you mute, we leave a point which we are explaining. Kindly be sensitive whenever you attend such a class virtually. So we are saying we are using an example of weight, a person's weight. We are representing weight with data W. We are saying that if we want weight of many people, we shall denote the weight of the first person using W1. So W1 stands for weight of the first person. Then weight of the second person is represented with W2, and so on and so forth, until you will reach the weight of the last person. Usually we denote weight of the last person as the nth person. So whenever you see nth, we are referring to the last person. You could be having 20 people, first, second, third, fourth. So the 20th person is the last person. When we don't know the last number, we usually represent it with n. So that's why here we are saying weight of the nth person, the weight of the last person, and we represent it with Wn. So if you have collected such data about people's weights and you want to sum up to get the total weight or the average weight, you will write a mathematical expression like this one. Weight of the first person plus weight of the second person plus weight of the third person plus weight of all the people in between until you will reach weight of the last person, who will represent as weight of the nth person. We are saying statistically this expression will be too long, yet the work of a statistician is to summarize data. Therefore, instead of writing such a long mathematical statement, we use an algebraic shorthand. We use an algebraic shorthand for equation 1, and we represent it with this equation you see here, summation of Wi, where I starts from 1 and reaches n. I will correct something small here. I'll correct something small here in this equation. So it is look at these numbers below this summation notation here. It is supposed to be I equal to 1. And on top, it is supposed to be I equal to n. I will explain what these ones stand for. So this expression 2 is representing expression 1, is the shorthand for expression 1. It is telling us that you sum up observations on a variable W, where the first person I is W1 and the last person I, the last person is Wn. In other words, when you combine these two expressions, you will say that this expression, summation of Wi, is equal to the expanded form here. Yeah, as you look at this summation here, that is how it is supposed to be. I equal to 1 below the summation symbol, and on top of the summation symbol, I is equal to n. This number below the summation notation, I equal to 1, is called the lower limit or the lower boundary, while the one on top of the summation notation is called the upper limit or the lower boundary. What does it mean? This means that we have observations Wi. We have I, the first person is starting from number 1, and the last person ends at n. So I stands for respondents 1, 2, 3, 4, and so on. Let's get an example here. If we find that weight of the first person is 50 kg and the second person is 60, the third weighs 40 and the fourth weighs 50. Then when they give you this expression, summation Wi, where I is from 1 to 4, meaning that you have all the observations given here, W1 up to W4. In expanded form, this expression is equal to W1 plus W2 plus W3 plus W4. That's this expanded form. If they tell you to expand this expression here, You expand it like this. Now, when we substitute these figures which were given here, we find out that W1 is 50. So where it is W1, we put 50, W2, 60, W3, 40, and W4, 50. When you sum up on your calculator, you will get 200. But if you are given another expression, which looks like this, sum up WI, I starting from 2 to 4. Now, these upper and lower limits will start making sense here. They are telling you that not everything is summed. You are going to start from observation 2 and you stop at observation 4. That's why we said it is the lower limit and the upper limit. They tell you the starting point and the stopping point of your summation. So when we expand this algebraically, we shall get W2 because they told us to start from 2, W4 plus W3 plus W4 because they told us to stop at 4. So when you substitute in these figures, according to the data given here, you will get 60 plus 40 plus 50, giving you 150 on your calculator. But they can write it in this format. Sum up WI squared from 3 to 4, meaning that square the observations of W starting with the 3rd and stopping at the 4th. When you expand it algebraically, it looks like this. W3 squared, because they told us to start at 3, plus W4 squared, because they told us to end at 4. So when you substitute in W3 is 40 and W4 is 50. Square them. When you square 40, you get 1,400, and when you square 50, you get 2,500. A total of 4,100 is got on your calculator. They can write it in this format. Sum up the observations of W minus 5 from the 2nd to the 3rd. They are telling you that for each observation of W, subtract 5, and then you add the differences, the remainders. But start from observation 2 and stop at observation 3. When you expand it algebraically, it will be W2 minus 5, because they told you to start at 2, plus W3 minus 5. And this is where they told us to stop. So when you do this, following, remembering your, how did they call it? A body mass in P4 mathematics. You deal with the brackets first. We substitute in first W2 and W3. Then we remove the brackets first. So we subtract 5 from 60, we get 55. Then we subtract 5 from 40, we get 35. When you add these two, we get 90. So just note that a summation notation can be written in different ways. All what you need is the ability to interpret what it wants or it requires you to do. In statistical formula, you will find these summation notations common. But if you don't know how to interpret them, you may think they are hard or difficult, yet they are not. It is just interpretation, and then you substitute and go. Always data is given. There is no big science there. So we gave you this introduction to familiarize you with the how to use summation notations when they are appearing in different formats. Note that when a summation notation involves all the available scores, we may ignore the lower and upper limits. So when the summation notations requires you to add up everything in the data given, the lower and upper limits may be useless. In other words, when you see a summation notation without upper and lower limits, it is simply telling you that sum up everything given. So when they give you such an expression, summation WI, it means sum up everything given. Just like you see here, since we have data on 4 observations, W1 up to 4, the summation WI I'm requesting Mr. Masembe to unmute you. I mean to mute yourself. Mr. Masembe. Members, we had said that when a summation notation does not point out the upper and lower limits, they are telling you to sum up every data given. Look at examples A and B here. Sum up the squared observations of WI. They are telling you that you square everything and you sum up everything, just like you see in this example. So I think that is an important point to note. Then we can go and look at summation notations involving 2 variables. We can look at summation notations involving 2 variables. Somebody is putting up a hand. Let me know. What do you want to say? You unmute and say it.
Excuse me, doctor.
Yes.
For example 1, where we have and part C, example 1, part C, where we have the square summation from I equals 3 to 4. I think I'm seeing the square part of it. The square part of it is on I, which is giving some a bit of confusion. And my understanding, I think it should be W, which is squared, then I as a subscript down.
Yeah, that is it. That is it.
Yes.
It is because I is simply standing in for a number. It is not a variable there. So we have one variable. So that is right. Thank you. Thank you. Any other issue, members? So if there is no any other concern, we can move on to summation, how to deal with the summation notations involving 2 variables. These are called univariate, bivariate summation notations. Now, bivariate means two variables. So when we say bivariate analysis, we mean analyzing data for two variables. We said in bivariate analysis, we need to use summation notations involving two variables. The two variables may be denoted as x, y. One variable is x and another variable is y. So you will have a symbol like summation xy, summation xy squared, summation x plus y, summation x minus y, summation x divided by y, and so on and so forth. So let's look at the example and we move on. If we are interested in the relationship between two variables, x and y, and the three observations or scores have been collected as given here, x1, x2, x3, y1, y2, y3. And you are required to evaluate the sum of the product of the corresponding observations. When they say corresponding observations, it means they are two pairs. Each one is a pair. X1 goes with Y1, X2 goes with Y2, and X3 goes with Y3. That is the corresponding we are talking about. Even when they say evaluate the sum of the differences of the corresponding observations. Now, for expression number one, where they say, A, evaluate the sum of the products. A product in mathematics means multiplication. So they are telling you that multiply the corresponding observations, then add. As you see in this expression here, we have said summation xy is telling you to sum up the product of the corresponding observation. X1 times y1 plus x2 times y2 plus x3 times y3. Since we have our data on each of the y and x, we simply say x1 is equal to 5. So we put 5 here times y1, we put 0 because y1 is equal to 0. Then plus. There is supposed to be a bracket here, for example, so that you can know which one to deal with first. You can put brackets like that to tell which figure to deal with. When you have this, then you bring your body mass mathematics and you say always we deal with the brackets first. Then after the brackets, we go to multiplication, which is the off. So here we shall have 0 here plus 0 plus minus 7, as you see it here, which will give us minus 7. If your mathematics does not allow you to get this, then you know that you have to go back to your mathematics. you go back a little bit, but this is simple. You can even grasp it from here if you had forgotten it. If you had forgotten it. So in example, in question B, they told you to sum up the differences of the corresponding observations. Meaning that you take the differences of the corresponding observations, which means subtract x1 minus y1, then plus x2 minus y2, plus x3 minus y3. Those are the corresponding. As I told you, y1 goes with x1, x2 goes with y2, like that. So as you see now in brackets, we substituted, then we took the differences. We substituted and we took the differences. So when you subtract 0 from 5, you get 5 according to your calculator. When you subtract 0 minus 2, what do you get, members? 0 minus 2. So this is 5 plus 0 minus 2. On your calculator, what do you get?
Drugs.
That's negative 2.
Okay, or 5
Negative 2.
drugs. So this these patients,
You get negative 2. That is true. But why is it that here we don't have negative 2? So it should be negative 2, and then this plus negative 1 minus negative 7, you should have minus 8. Now, what is the right answer here? You have 5 plus minus 2 plus minus 8. What is the answer? The right answer there, according to your calculator, members?
Negative 5.
Negative 5. So, okay, let us say here that we shall have an equal sign of 5 plus
going to record.
minus 10.
Hey,
You can even ignore the minus, I mean the plus.
This is what it goes to. This number 1.
So this automatically
It is always
gives you
number 1.
minus 5.
Yeah.
Abdul Salam. Abdul Salam. Kindly keep yourself mute. So members, we have collected this, also collected from your material. Note that where there are 2 or more variables, it may be easier to use a table to solve summation notations. So let us repeat example 3 using a tabular approach. We are required to sum up the products of the corresponding observations. We could write a table as illustrated here. This table, the first column is of x and the next column is of y. We put the values of x here as they were given 5, 0, negative 1, and put values of y, 0, negative 2, and 7. Then x, y. This means x times y. x times y. So you simply multiply 5 times 0, you get a 0. 0 times -2, you get a 0. And then -1 times 7, you get a -7. So you sum up this column, you get summation xy, and it gives you a -7. It is easier to solve using a tabular approach when you have more than one. Let me say you have two summation, two variables or three. Even if it is expressed like this, that you sum up the differences of the corresponding observations. As you see here, there are no upper and lower limits. They are telling you that you sum up everything. So here we get a table like this. We put x values and y values, and then here we put x minus y column, where you subtract 0 from 5, you get 5. You subtract, by the way, this is a subtraction, and this is a negative, by the way. We could have made a mistake. When you say 0 minus -2, it will give you a 2. So maybe you made a mistake somewhere. And then here, -1 minus 7, it gives you a -8. So when you sum up this column, it will give you a -1 as the answer for that expression. I think, members, even the other example, let us look at it politically, where we collected here, but this were, remember, this is a 0 minus -2. So this is where I made a mistake. So when you add these two minuses, you get a positive. So that's why here it remains 2. And here it will be 7 minus 8, which will give you a -1. Sorry for that, but it is also giving us a familiarization of how to calculate. I'm seeing Emmanuel with a hand up. Kindly unmute yourself and you tell us.
Yes, Doctor, that is what I wanted to raise, because I was seeing you changing to -5, because I knew when you subtract 0 from -2,
Yes,
you get a +2, because yeah, so that's what I wanted to raise.
okay, thank you. It was a slip of the what members can tell. There is something that had slipped. So that is how to solve summation notations using a tabular approach, especially summation notations involving 2 or more variables. We shall go in a break after that. Then we shall come back with another unit, unless there is a question. If you have a question, unmute and you ask. Merito, you have a question? Merito, you have a question?
Oh, class, really. This, yeah, that's what I think.
Come
I think
on.
this online thing really will need to work. As much as
Okay, if nobody has a question, then we think we have prepared you enough. We are going to move on to data analysis. All what we have done since we started was just to prepare you for data analysis. Now you are ready. You know how to use summation notations. You know how to classify variables, and therefore how to determine the analysis tools. Then we can begin the data analysis. The next unit is on data analysis. We are going to see that data analysis is divided into two branches. We shall first of all deal with descriptive data analysis, and then later we move on to inferential data analysis. The descriptive analysis tools, as we gave in the definition at the beginning of this course, we defined what descriptive means. We showed that descriptive analysis deals with the processing, analysis, and the interpretation of data for purposes of explaining a sample only, with no intention of making generalizations to the whole population. So that is what we are going to go